Hello and welcome to a new R Labs tutorial. Today we're going to be discussing how to remove NA's missing cases from R data frames. To begin with, it's worth distinguishing between NA and NaN. NA means a missing case, so where a cell within a data object in R has no value, whereas NaN stands for not a number. And not a number can be derived where you try and perform a mathematical operation on elements that are non-numeric in R. Before we begin to remove and strip out these missing cases that can be problematic for forthcoming analyses, we have to explore and summarize where these NAs are within our data. To do this, we can use simple summary and exploration functions like structure, straw, head, and tail. One of the most useful functions that you'll find here is the is.na function. This has the ability to assess for a given element or all elements of a R data object if a missing case is present, and it will return a logical value. So it will return true if a missing case is present, and false if there is no missing cases. Is.na is most powerful when it's combined with other functions and nested within them. So for instance, nesting is.na within any will return one value for a given R data object that will say if any of the elements of that object have missing cases. Similarly, another really powerful function is nesting is.na within colsums. This will give you a summary of the number of missing cases for each column of your dataset, allowing you to locate where the majority of the missing cases are. Once you're happy and understand where your NAs are distributed within your data frame, you may want to then go ahead and strip out these missing values. To do this, we use the function na.omit, or alternatively, complete.cases. One of the subtleties that I hope to explain in this tutorial is the problem of using these quite harsh functions, as it has the potential to massively reduce your sample size. Okay, so let's move over to RStudio. The dataset we'll be using is the air quality dataset from base R, and we can assign this directly to a new data frame, my.data. I know that this sample dataset already has some NAs, but I'm going to be cheeky and add a few more. So let's go right ahead and get stuck into using the is.na function. This returns true value for if an element within a data object has an NA value. So let's print this to the console. And what we'll find is that there seems to be a lot of missing cases for final column, and the whole final row also seems to be full of missing cases. A simpler way to summarize this is to nest is.na within any. And this will return one value for the my.data data frame, which says, yes, there is missing cases within this dataset. Let's start to get a feel for how this new my.data is arranged. There are 7 variables and 154 observations or rows. Seems like the 7th variable, as we've discussed, as I mentioned earlier, has a strange name and is full of NAs. So we may want to strip this column out of the dataset before we continue. If we run the head function, this confirms again that the 7th column just seems to be full of NAs. And if we run the tail function, this confirms that the final row, row 154, is also completely full of NAs. So let's go ahead and start to exclude these columns and rows. We can call my.data and index all columns except the 7th column, and then assign this to a data frame called my.data. Because we're using the same name here, we're actually going to override the my.data and strip out the 7th column. If we then run the tail function, we'll still see that we need to strip out the final row, row 154. This time, when we index my.data, we want to address the rows. To do this, we need 2 inputs within the square brackets. The first refers to rows, the second refers to columns. We want all rows to be included, excluding the final row, row 154. And if we run the tail function again, yes, this looks like we've had some success. Okay, so now we might want to go on And after we've stripped out these superfluous rows and columns, let's see if there's any missing cases left within the main body of our data frame. We'll run the is.na function nested within na, and yes, it seems like there's still some nas within our data frame. We may want to get an idea of the extent of this problem. So to do this, we can use the is.na function nested within sum. And this tells us that there's 44 missing cases within our data frame. If we want to get a more precise idea as to where these missing cases are distributed, we can maybe start looking within certain columns. So to do this time, instead of calling the whole data frame, we're now looking at just one column, the solar radiation column, and there's 7 missing cases within that. We could then reproduce this one line of code and index one by one the 6 different columns. This seems a bit inefficient as it would be 6 lines of code, so instead let's use the really great function col_sums. Excellent. So it seems like the majority of the missing cases are within the first column, the ozone column. Then we'll find some within the solar radiation column. And there's none in these climatic variables and date variables. Now we've described and have an idea as to where the NAs and missing cases are distributed in our data, we may want to go ahead and start stripping out and removing all rows that contain any missing cases. To do this, we can use the function na.omit. And we'll find that we're now left with a sample size of 111 observations. Alternatively, instead of using na.omit, we can use the complete.cases function and index for my.data the columns where there are complete.cases. And this will again give us exactly the same number of observations, number of rows. One problem that we have with this is it massively reduces our sample size. Previously we were up above 150 and now we've been reduced right down to 111. If we're wanting to perform statistical inferences for a certain question, it's important to have the largest sample size we can get to a certain extent. One way to minimize the reduction in this sample size is only to strip out rows with NA values for columns that are relevant to the analysis that we wish to perform. Let's say, for instance, then, we wanted to build a model to see whether solar radiation predicted climatic variables like wind and temperature. The model that we might want to fit to address this question doesn't include ozone, so we wouldn't want to diminish our sample size by stripping out these rows. A better approach may be to exclude the ozone variable from the dataset, as it's not going to be used for the analysis, and then perform na.omit on these columns. And hopefully that will leave us with a greater sample size. Okay, so now we're going to call na.omit on the data frame with all columns excluding the ozone column and assign this to a new data frame. If we then look at the number of observations for this data frame, we'll see that we're back up to a really high number again, back up to 146. So we've only lost these 7 missing cases. If you have many columns and you want to strip them out according to some measure of quality of the data, you may want to perform something similar to this. So we're going to reassign my.data. We're going to leave in all the rows, but we're only going to transfer across columns that have less than 10 missing cases within each variable. From this new data frame, we can then strip out the NAs and we can summarize the sample size that we're left with. And in this case, it's exactly the same. To summarize, we've introduced the difference between missing cases and not a number. We've shown you how to explore and summarize how NAs are distributed through data frames, and the importance of nesting is.na within other functions. Finally, we've introduced you to the functions na.omit and complete.cases. In doing this, we've also made you aware that these functions can be a bit brutal in stripping out observations from our data set, and we've shown you some alternatives to how you can mitigate this effect. Thank you for listening to this RLabs tutorial video. If you found this useful, you may be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.